Thank you. Yeah, as you mentioned, I'm Dr. Jacob Nectarline, founder and president of Elementum 3D. We develop new materials for additive manufacturing or 3D printing. Next slide, please. So really what we do is we supply materials and we supply the entire chain of how to develop, use, and post-process those materials for the 3D printing market. We've developed new alloys like aerospace grade aluminums for a very heavily aerospace grade market. Next slide, please. So what makes this different? Well, typically you can't print these very high strength aluminums for the same reason you can't weld them. We've solved that problem with our reactive additive manufacturing process, and we've been able to then provide a menu to engineers. Next slide, please. It really opens up the possibilities to all sorts of different alloys, not just aluminums, but in this case, there's no Goldilocks material for every application. There's no Goldilocks material. For example, maybe an engineer wants a high thermal conductivity or a higher throughput or a higher strength. We really provide that by being able to supply materials that are either equivalent to the raw materials that are available or new materials that weren't possible to make without 3D.
Randomly generated.
Next slide, please. So I think it's really important to back up and talk about the business cases. So why 3D printing? Why additive manufacturing? There's three primary business cases and then one that's up and coming. The first, lightweighting. Typically, that's not a business case on its own. That can be helpful and attached to the other business cases, but it's not typically a good enough case on its own. But printing designs that you can't otherwise is really important. This is really taken over in a lot of industries like rocketry and others. But being able to make cooling channels that hug contours or manifolds that wrap and direct fluids in different directions, really complex antennas, that's really where additive manufacturing can shine. The next business case being combining parts. The ability to be able to take, say, for example, a helicopter engine that was 900 parts and make it down to 20 components. Being able to keep track of the supply chain is so much simpler. And then also being able to repair these parts. Imagine a repair technician. Maybe there are some really special people out there who can keep track of 900 parts, but it's far easier to imagine someone who knows these 20 components, knows which parts to repair, which parts to replace when it's only 20 parts. And I think that's an important aspect to this of being able to simplify that supply chain, simplify the parts, simplify the understanding of how these different really complex systems can work. And then the newest business case that's really up and coming is the logistical improvements. Reduction in warehousing to where you can really decrease the size and number of extra parts that you had to make in the original production. Improving the national security. Imagine a forward operating base where basically you can ship the material and it's just a lot of metal powder, and then you can email over a secure chain directly to the front line the really complex and difficult to control parts. Next slide, please. So what makes Elementum different? Well, we developed these new alloys and they're great and they do a lot of different things. They're very high strength, but the most important part that we've gotten feedback on is the consistency. Being able to have the same results and the same strengths, everything be exactly the same from print 1 to print 10,000 is incredibly important. And so having this wide process window and therefore really consistent product tends to be more important than peak strength or anything else. Although we have high strength materials available as well, it's really about consistency. And so we like to demonstrate that by providing fatigue data and really testing a lot of these materials. Next slide, please. As part of that, we have flight heritage. We have parts flying today. We have parts in space. We have parts that have gone through all the way through to an A basis equivalency, an MMPDS, and have parts with obviously our customers like Ball Aerospace, Orbital Microsystems, Northrop Grumman, Lockheed Martin, and where we help them realize their designs and make their designs out of high strength materials. And we've spent quite a bit of money going after the data to be able to support that, to sell that to the end customer, which is typically DoD, DOE, those sorts. Next slide, please. I'm going to touch on this briefly. We now have 50 employees. We're moving into a 76,000 square foot facility and really have gained some traction. We have a team that's dedicated in developing new materials and alloys for additive manufacturing exclusively, with over 45 years of experience at the PhD level. Next slide. An important part of that, I mentioned a couple of our customers before. We have really close relationships with them. Northrop Grumman goes to trade shows and talks about our 7050 Ram 2. Ball Aerospace goes to trade shows and writes articles about our 6061 Ram 2 and how it's working and why they're using it. But we have really close relationships with our suppliers as well, and the suppliers of the printers. And we do quite a bit of different government contracting, both as the prime and as the sub to a lot of these companies. And there's plenty more that we can't talk about as well. Last slide, please. So what are we looking for? We're looking for expanding and adding more partnerships and relationships with customers to leverage our materials and our manufacturing capability with their manufacturing's background and their materials and design background as well. So we really pair well with a lot of the larger companies and can go after all sorts of different projects ourselves as well. And we're looking to go into projects on weapon systems, aircraft components, all sorts of things. So yeah, thank you for your time. Any questions? Happy to answer them.
Thank you, Jacob. Opening the floor, Han, go ahead.
Yeah. Question actually. So I know you have some, you presented some fatigue data and things like that for your solution, but how do you get around? You know, the 3D printer parts are usually generally not as dense as a part made by like CNC and other processes, right? So can you kind of, could you comment on that a little bit and how your product is, how your solution is actually overcome those typical problems?
Yeah, so laser powder bed typically doesn't have that problem. So we can dive further into that, but there are multiple different types of printing, particularly laser powder bed. I mean, our 6061 is 99.98% dense, which is far more dense than a casting and as dense as any forged part as you're looking for. So certainly we're getting properties that match that or beat that of the wrought materials.
Right. Thank you. Appreciate it.
Perfect. Bob?
Yeah, you're selling materials, and are you also acting as a service bureau to print parts?
So we do have 8 printers in-house, and that's a significant capital investment. But those printers are really dedicated to producing first components and then helping that kind of pilot factory stage that we can then transition to the OEM, say Lockheed Martin, Northrop Grumman, whoever they are, and really help them then support their own production with their own components so that we're selling the material. So we're not trying to compete with our customers, but we are trying to provide a service where we can help them get started.
Okay, thank you.
Perfect. Dana, the floor is yours.
Yeah, sure. So we've done a little bit of analysis of the supply chain for 3D printing, and we're quite frankly a little bit alarmed by the few number of suppliers of powders, whether they be advanced powders like you're talking about or just the more conventional stuff. I wonder if you could comment on who you see as your primary competition or who you may be seeking to disrupt in the market. I don't know if you can name names or if you just want to talk about it more generally.
Yeah, so certainly there are competitors, and I think that's really a healthy thing for the stage that we're at. And it's one of the reasons that we're going up that vertical to be producing our own powders is there's a really well-established supply chain for the billet material. I mean, we can source 61 aluminum very easily. There's a huge 100-year-old supply chain there. And so there are a number of competitors out there that we also see as partners, and we work with them a lot. Praxair, Carpenter, Valamet, these are good suppliers for us so that we have multiple supply directions, but then also, somewhat competitors as well. But there's a large enough growth in the market that we're seeing more and more powder suppliers. We're seeing more and more supply chain solidification. And it's important for us in that there was really only one aluminum supplier in the United States that was doing any real volumes. And so we want to help supplement that so that we have 2, because all of our customers were saying we at least need 2 in the US. And there are others, there are some in Canada, there are some in Europe, but we're really looking to establish ourselves as an aluminum supplier in the United States as well, out of Colorado.